Hey everyone, so these are the topics I'm going to go over in this video. They all relate to things with the calculator. Just so you know, there's also another video already on the YouTube page that has to do with how to do the statistics in the calculator, hitting L1, and how to pull up the quartiles, median, mean, all of that. Okay, so that's already on there. I'll link that through the Regents review folder as well. The first thing I want to go through is just fixing your window. So if you go to your calculator and you hit graph and it looks like this, it looks uneven. I just want to remind everybody to fix that, hit zoom, and then pick 6 for standard. Okay, then it should go back to normal form. So we're going to start off then, besides that, going through the min and max and zeros of a parabola. Now obviously a parabola only has a min or a max, but the process is very similar. So if you go to your y equals, okay, I'm going to pick a sample one to start. So x squared minus 5x plus 6. And I'm going to hit graph. We can see that this calculator is opening upwards, so it has a minimum. So to figure out what that minimum value is, because it does look like it's going to be a decimal here, hit second, then trace, and you're going to pick 3 for minimum. If the parabola had a maximum, you'd pick 4 for maximum. Okay. Then the calculator is going to ask you for a left bounds, which just means a point that's to the left of that minimum. This is also in a way giving you the vertex or turning point as well. For the right bound, pick a point on the right, hit enter, and then you're going to hit enter a third time. At the bottom it'll tell you what your minimum is. This we can round to 2.5 because it's going on. So the x value is 2.5. The y value, or the lowest value, the minimum, is negative 0.25. If we want to find the zeros of this parabola, that's where it crosses the x-axis. So it's a very similar process, second, trace, except I'm going to pick 2 for 0. Now we can see, if I move my cursor out of the way, there's 2 zeros here. Okay, and we can see that it looks like 2 and it looks like 3, but we're going to verify that. So with the first 0, I'm going to pick a point on the left, pick a point to the right of it, and then hit enter a third time. And it tells me 0. The 0 is when x is 2, y is 0. To repeat that process for the other one, go through the same thing, second trace 2, except now you want to point to the left of the other 0, 1 to the right, hit enter, and you get 3, 0. So you can also check the zeros as long as they're integer values on the calculator. If you look here at 2, you have a 0, at 3 you have a 0. That's what you're looking for. And zeros are the same thing as roots. Now if your parabola, I'm just going to change a couple things in here. I'm going to change this minus to a plus. And I'm going to change this plus to a minus. When I graph this, I can't see my min or max anymore. I could still calculate the zeros and do that, but if you want to find the min and max, you have to change the window. We can see that we need to go lower on the y-axis. So when you hit window, we want the minimum y value to be lower than negative 10. So let's try negative 20. And this is all a little bit of guess and check. Now I can actually see where it is, and I can go through the same minimum process again. Now if you want to fix that and you want to go back to your graph as normal, remember zoom, 6. Always puts it back in standard form. Okay, so that takes care of our first 2 topics. Next, for intersections, this is when you're solving a systems of equations. I'm just going to reference page 8, number 37. You're looking for the answer to a system of equations, which means the point or points of intersection. So I've already gone ahead and typed those into my y equals. That second question, or the second equation, had to be solved for y in order to type it in. If I then hit graph, remember to pause at any time if you need to slow down. I get an upside down parabola, and I get my line. Now, if you need to zoom in, hit zoom 2, And that might help you see things a little bit better. Remember, if you always want to fix it and go back, hit zoom 6. The reason I'm zooming in here is so you can see that there are actually 2 points of intersection, one here and one here. So to find the intersections, we're going to hit second, trace, and pick 5. And we want to get really close to that point of intersection. Okay, I'm close to it, so I'm going to hit enter, and hit enter again, enter a third time, and I see my first point of intersection is 1, 1. But there's going to be another point of intersection, so I have to repeat the process. So second, trace, 5. Go close now to the other point of intersection, hit enter 3 times, and my intersection is 1.5, 1.25. You have to make sure that you check this through this method, because if I go to my table of values, those fraction or decimal intersections are not going to show up. I do see the match at 1, okay, that the y1 and y2 columns match, but I can't see it for the other point. So remember to use that intersect rule in the calculator to check it. Next, I'm going to do a linear regression, so I'm referencing page 40, number 35. And if I go to my calculator, I've already typed those values into L1 and L2. Now you all should have the residual column in place. Until you do the linear regression, the residuals are not going to show up here. However, in this particular problem, they already put them in a column on the problem for you in the green book. Okay, so you didn't have to calculate them on your own. Once those are in our calculator, we're going to hit Stat, arrow over to Calc, press 4 for linear regression. If you have this calculator, you're going to arrow down to Calculate. If you don't, you need to type in L1, comma L2, and then hit Enter. Okay, so here's my linear regression. It tells you to round to the nearest hundredth. So it should be y equals 43.49x. And then since this is negative, minus 87.57. I want to mention what R, the correlation coefficient, is. This one is 0.9, right, 0.908. That means that it's really close to 1, so this is a strong correlation coefficient. It indicates that the linear regression is a good fit for all of the points. The closer it is to 1, the closest it is to negative 1, okay, the better the fit of the regression line. From there, in part B, it says create a residual plot. So what you would do for part B, if you're looking at your green book, is take the weak column that says X, the residual column that starts off with 55, and plot them. Now if I go to my calculator and I go back to Stat 1, you can see those residuals showed up here, okay? And in the green book, they just rounded for you. When you draw your residual plot, so let me make a little note of this here. If, and I'm going to freehand this in a second, I'm going to show you what a good one and a bad one would look like. And you would have to explain this in your own words. Your residual plot in the book for this should look something like this. This is bad. Okay, because it forms a pattern, it looks like a U. We don't want it to look like that. Instead, you want it to be kind of scattered, okay, and no real pattern to it. This over here would be a good residual plot. So in the question on page 40, it says determine if the equation is a good fit. You would say, based on the residuals, it is not, since the residual plot forms a pattern. I just want to quickly show you how you would do an exponential regression as well. So first I'm going to clear out this data. So remember, you don't hit delete, you hit clear and then enter when the top line of the column is highlighted. Clear and enter. And again, don't worry about the residuals. I'm going to make up my own values. I'm just going to do a couple here. And I'm going to make one that works out really well. So I'm going to say 3, 9, 27. Okay. We can see that this is exponential rather than linear because it's changing via multiplication. Each term is being multiplied by 3. If I want to create an exponential regression for this, I hit Stat, arrow over to Calc again, but now just scroll down a bit, and it should be at 0. At 0, you want exponential regression. Hit enter. You follow the same process as before. And you see here's your format. A times b to the x power tells you a is 1, b is 3. And since in that case I picked one that was perfectly exponential, we can see the correlation coefficient is 1. Okay, moving on to piecewise functions in the calculator, I'm going to reference page 6, number 31. Now I did this problem in one of the earlier videos, but I just want to show you how to check your work in the calculator for this. So let's go to your y equals, and I've already started typing in the first piece of the piecewise function. I'm typing it in parentheses. What we do to show that we only want when x is less than 1 is we hit the division sign, and then in parentheses we're going to type that. To get to less than 1, you need to hit second, then the math button, and there are all of your symbols. So I'm going to pick 5 here, close my parentheses, and then I'm going to do the same thing on the next line for the other piece. So x plus 2 divided by, in parentheses, we want x is greater than or equal to 1. And now watch what happens when I graph this. You can see, and I'm glad I did this, and I did it by accident, but I'm glad it happened. I can't see my second piece, so I gotta fix it. Zoom 6. Now my parabola is gonna graph, it's gonna stop, and the second piece is going to start. This problem asks us to evaluate f of negative 2, so go to second graph for your table. At negative 2, the answer is 11. Okay, the other function will give you an error because it doesn't work in that interval. Okay, last we're going to make sure our calculator is ready for the Regents, so you can pause it on this list and check all of these things. I'm just going to go through them in a different order. First, I'm going to make sure our plots are not highlighted. So if I hit y equals, the words at the top, plot 1, plot 2, plot 3, all should not be highlighted. If they are, you just arrow up to it, hit enter, and that should deselect it. While we're here, let's also clear out all of our y equals, and that means scroll all the way down to the bottom, okay, make sure all of them are empty. Otherwise, that could cause you to get an error. Let's also put our graph back. And once you're done, move back up to y1. Let's put our graph back to normal in case we moved it, so hit zoom 6. And we see everything that we need to do to graph for tomorrow is good, or for Tuesday. Then let's take care of our statistics. Stat 1. We want to clear out these columns so that they're ready for use and we don't accidentally delete them on the test. Hit clear once L1 is highlighted, and then enter. For L2, clear, and then enter. Everybody should have a residual column in place. If not, I'm going to delete mine by accident, so if you have yours, don't do this. And I'm going to show you what to do to get it back. Okay. You're going to hit second, and then insert. And you're doing this while L3 is selected, okay, because that's where we want to put our column. Now, if you see at the bottom, it's asking you to name it, so you're going to hit second list. You should see 7, or residual as an option. Mine's 7, yours might be something different. Then hit enter, and it's back in place. Don't worry about the fact that there's numbers in there. Okay, a couple more things. If you hit program, there should be nothing listed there at all. If you hit apps, the only thing that should be there is finance. If you do have apps or programs, what you need to do to delete them, second, plus sign, 2, arrow down to what you want, whether it's programs or apps. So say it's apps that you want to delete. Hit enter. They'll be listed here. You hit delete. It's going to ask you if you're sure, and you say yes. Quickly, one last thing. Second quit to go back to your main screen. Second, 0. Press X to the negative 1. Look where mine's highlighted. You're going to arrow down until you get to diagnostics on. When you're there, hit enter, enter again, and you're done.